So you can finally use L'Hopital's rule. And here are some intermediate forms. If you have these two forms, that's the time that you should use L'Hopital's. If you have if you have 0 times infinity or infinity minus infinity, you should try to algebraically rearrange into the two forms that you can use L'Hopital's to solve the problem. And if for some reason you have 1 to infinity, 0 to 0, or no, 0 to infinity, and infinity to 0, then you take the natural log of both sides. That's just some rules that you should know. L'Hopital's rule, or this is what it follows. So you have a limit as a approaches, or x approaches an a value of f of x over g of x, and you happen to have 0 over 0, or infinity over infinity. So then you write next to it what you have. Then you put an equal sign. On top of it, you put L apostrophe H. And you need to show that for them to give you credit, to show that you used L'Hopital's rule. Then what you do is you take the derivative of the top over the derivative of the bottom. And then you solve it. And if that doesn't work, you do the L'Hopital's rule again, and you keep going. Sometimes you get the same thing back, so you have to be cautious. Then you try to manipulate it or to solve it without using L'Hopital's rule, and it should work out. You guys all learn L'Hopital's rule in high school? No? What? Does it seem hard to any of you guys? No, it's just taking the derivative over the derivative, so we can do a problem. Okay. So for this example, we have limit as x approaches pi of pi minus x cotangent of x. So first thing you do is try to put in pi for x. So as x approaches pi from the minus side, we have, if x is approaching pi from the minus side, it then means x is a smaller number, so we have a 0 from the positive side times negative infinity. And as x approaches pi from the positive side, we have 0 minus times negative infinity again. Or no, this time it's positive infinity. But these are both similar to that form which I showed you guys before. 0 times infinity. What happens if we get that form? What happens if we get 0 times infinity? We rearrange it to try to get 0 over 0 or infinity over infinity. Okay? So then we can use the L'Hopital's rule. So we have cotangent of x here. We can rewrite this as limit as x approaches infinity, or sorry, pi of pi minus x divided by tangent of x. Okay? Now when we put pi in here, we have 0 on top, and tangent of pi is also 0. Do you guys all see why tangent of pi is equal to 0? Because sine of pi is 0. So then we have 0 over 0. We put the equal sign with LH on top, because that shows we're going to use the L'Hopital's rule. So then we rewrite it, limit as x approaches pi. The derivative of the top is -1. The derivative of tangent x is secant squared x. So that's equal to -1 over, if we put pi in here, that's equal to 1, because this is equal to 1 over cosine squared x. Cosine of pi is 1, so this is -1 over 1. So our answer is -1. Any questions on that? The thing that you have to just recognize, since it's 0 times infinity, we can't just do the L'Hopital's rule. We have to put a 0 over 0 to do it. And you will need to show all of that on the exam. You guys have it written down? Alrighty. Limit as x approaches 0 of 1 plus x to the power of 1 over x. If we were to put in 0 for x, we would get 1 to infinity. Okay? If we get 1 to infinity or 0 to 0 or infinity to 0, we need to use natural logs. So what we do here is we set y equal to our function 1 plus x to 1 over x. And now we do the natural log of both sides. So we get natural log of y equal to 1 over x times the natural log of 1 plus x. We were able to bring 1 over x down because log property. Now we do the limit as x approaches 0 to both sides. So x approaches 0 of the natural log of y equal to the limit as x approaches 0 of 1 over x times the natural log of 1 plus x. If we do, so since this is times 1 over x, it's essentially equal to all of it over x. If we add 0 in here, what is the natural log of 1? 0. So we are left with 0 over 0 again. So now we know we need to do the L'Hopital's rule there. So we can actually just do equal to L'Hopital's. We need to take the derivative of both. What's the derivative of 1 plus x? Or natural log of 1 plus x? 1 over 1 plus x. So that's equal to the limit as x approaches 0 of 1 over 1 plus x divided by the derivative of x is just 1. So this whole entire part, if we plug in a 0 for x, we get 1 as an answer. So we have two sides now. Therefore, the natural log, so we have the limit as x approaches 0 of the natural log of y, now equal to 1. We're not done yet. Yeah. So one thing that we can do with that is we can take the natural log of the limit as x approaches 0 of y, and then set that equal to 1. So essentially we took the natural log out. Okay? If we do that, we can put everything to the e power. So we'll have therefore y. If we do that, the natural log, therefore we'll have the limit as x approaches 0 of y, and our y was the original function, 1 plus x to 1 over x equal to e. And this is actually a very famous definition of e. 1 plus x to the power 1 over x. Which part are you guys confused on?
So our answer isn't 1.
Yeah, our answer is e. The natural log of y is equal to 1. Okay? As the limit of f is x. But we're trying to find the limit of not the natural log, but of just y alone. Okay? So then we have to do e to the power of the natural log of the entire thing. So then we have to do e to the first power on this side. Okay? Any questions? You guys are so confused?
So whenever we have to take natural log, we don't have to like do the y stuff. And we don't have to natural log, we don't do the y stuff.
If you have the form like 1 to the infinity and stuff, then you need to do the natural log to solve it. But since we took the natural of both sides, we need to do the opposite, which is take e to both sides to get our answer. So any more questions on that? And I might have written it wrong. It's the other way is when you have 0 to 0 power, not 0 to infinity. So if you have 0 to 0, you also need to do the natural log. And when you have infinity to 0. Are you guys good? So now looking at rates of growth. So if we have limit as x approaches infinity of f of x over d of x, and we get infinity as our answer, what does that mean? Yep. F of x grows faster than d of x. If we get limit as x goes to infinity of f of x over d of x equal to 0, then what happens? F of x is slower than d of x. In the last situation, limit as x approaches infinity of f of x over d of x is equal to L, which is any number that does not equal 0. What does that mean? So f of x is the same rate. So for these, throughout the process to get 0 or infinity or anything, you will or you may need to use L'Hopital. Like, it's just solving the limit and then looking at what you have as your answer. So we have limit as x approaches infinity of e to the x times x squared minus 1. So I want you guys to try it and see what you get. Oh, sorry, it's x cubed minus 1. Did they? They might have done it in the video. There's an 8 GB flash drive right here. Yep. Yep. Okay. So what do we have here? So we do the local 12. What's the derivative of e to the x? Yep. What's the derivative of the bottom? I need to write limit as x approaches infinity again, or I will lose. So what do we get here? Yep. What's the fraction? E to the x over 6x. Okay. What do I do again? So I have now e to the x over 6. That's equal to infinity. So we know e to the x goes factor. Good. Can I erase this? What? Oh, yeah. So now we have, this one I'm going to tell you f of x is equal to the square root of 3 plus x plus 4x to the 6. G of x is equal to x cubed minus 3, or x cubed minus 1, and then you guys solve it. It's x to the 6th. What did you get? What does that mean?
Oh,
Same rate. Yep. Where did that jump? So we write the function limit as x approaches infinity of f of x over g of x. So we have 3 plus x plus 4 x of 6 divided by x cubed minus 1. To solve it, we need to multiply top and bottom by 1 over x cubed. We get x cubed because we have a 6 inside the square root. The square root of x to the 6 is x cubed. So this is equal to the limit as x approaches infinity of the square root of 3 over x to the 6 plus 1 over x to the 5 plus 4 divided by 1 minus 1 over x cubed. Since we're going to infinity, 3 over x to the 6 goes to 0, 1 over x to the 5 goes to 0, 1 over x cubed goes to 0. We're left with square root of 4, which is equal to 2. That means f of x grows at the same rate as g of x. As x approaches infinity. Are you guys good with that? Now there is the whole deal with big O and little o, but I prefer not to go over it unless you guys really want me to, because I need to relearn it too. Nope. Yeah, I can show you guys those. So one thing I will say about big O and little o is you just do what they did with their problem, and it's the same procedure almost always. Okay? So if you just go back to the examples they did in class, it works out always the same. Yeah. But yeah, it is rates of growth, but you have to realize that little o means that they're not opposites, little o and big O. Little o means that it's just slower, big O means it's slower or equal to. What? It doesn't mean it's faster. Yeah. Or if it's slower than.
Yes. But you should basically make it slower than equal to.
Yeah. Yeah, that's it. And then you have improper integrals, which really aren't that tough. You just have to recognize that it's going to be improper at some x value. And then you solve it like a normal integral. But when you put in your limit, you use limits. So we have a to b of f of x dx. So it's improper if first way is a and or b is equal to infinity. And the second way is f of x becomes infinity while on the interval from a to b. So you could either have infinity at a or b, or say we're going from 0 to 3, and at 1, the function becomes infinity. So then you would have an improper. So let's do an example. And with this, the way you show your work really matters. So we have the integral from -1 to 1 of x to the -4 dx. Where would we break it apart? At 0. So we need to rewrite this as the limit as b approaches 0 from the minus side.
You have to write this interval is improper because.
No.
I think he actually asked you. And he would like to you when you're going to say why is this interval improper? That's what he said.
Did he? Yeah, on the practice exam, he does say state why it's improper. So we'll do that. But we do break it apart at 0. So b at 0 approaches from the minus side of x to the -4 dx plus limit as a approaches 0 from the positive side of a to +1 x to the -4 dx. And since he does want to state it, we can say is improper since 1 over x to the 4 goes to infinity when x is equal to 0, or as x approaches 0. So you do need to state that. So you guys can solve it. What does an integral represent? The area. So what do you guys get as an answer for that one? Sure. Yeah. Exactly. Okay, let's just do it. Limit as b approaches 0 minus. What's the integral of x to the -4? X to the -3 over -3. You need to remember -3. Yeah. And then we need to show that we're going from a -1 to a b plus limit as a approaches 0 from the positive of x to -3 over 3 or -3 from a to 1. You definitely need to show the a and the b, or you lose all your points. No. What? Yeah, you have to break it apart into two functions since 0 comes in the middle. So this is equal to negative 1/3 times the limit as b approaches 0 minus. Now we need to add in b, so we have 1 over b cubed minus a negative, so it's plus 1 essentially. Close parentheses, plus the limit as a approaches 0. This time we add in 1 first, so we have 1 minus 1 over a cubed. And then we close. So we still haven't substituted 0 for b yet. And you need to show all those steps before you do. Okay, now we sub in the values for a and b. So we're left with equal to negative 1/3 times, when we sub in 0 from the minus side for b, we get infinity plus 1, a negative infinity plus 1 plus 1 minus a positive 1 minus a positive infinity that is equal to, so here we have a minus infinity, and a negative sign on the outside. Okay, so this is equal to what? Positive infinity. And what does the infinity mean? Yep. So therefore, the integral from negative 1 to 1, x to minus 4 dx diverges. This means that the integral has an infinite amount of area from negative 1 to 1. Okay? So if you were to paint a physical wall from the coordinates negative 1 to 1, but the function of that wall was 1 over x to the 4th, you will never be able to paint all of it. You'll need an infinite amount of paint to paint. Now say if it was like 1 over x cubed or something, or some function similar to it, the area turns out to be a number, then you will be able to paint that wall. So even though this is limited from negative 1 to 1, you'll never be able to paint it. Yeah, it's impossible for it to exist. So any questions on that problem? The thing that you really have to pay attention is showing that you're taking the limit of the function and showing the variable when you show the limits. Then when you do this step, you need to show that you plugged in that variable into it with the limit still on the outside, and then you can show the work. Good. Let's move on to the direct comparison test. Can I erase this? Okay. The direct comparison test, you need two conditions to be true. So the first condition I have here is f and g are continuous on interval a with a bracket, infinity, and 0 is less than or equal to f of x, which has to be less than or equal to g of x, for x is greater than. Now those conditions have to be true. But we'll just move on. So you do the integrals for both functions. Just have this in your notes. What? 0 or g of x has to be greater than f of x, which has to be greater than 0. For x has to be greater than or equal to 8.
Wait, what?
X
0
greater
less
than
than f of x and less than g of x and.
x is greater than or equal to a.
Okay.
So since we have we know that one of them has to be lower than the other one, right? So we're saying f of x is the smaller. Like the function is small. This is backwards in here. Do they cover that in Dino? Like the function is x squared is smaller than x cubed.
That's obvious, but they did really pretty crap.
Yes. Okay. So then it's essentially realizing if you have something small that diverges, then what does it mean for the bigger one? The bigger has to diverge as well. Did that make sense? If the smaller quantity diverges, so if the integral from, let's do a to infinity of f of x diverges, then the integral from a to infinity of g of x diverges. Okay? Did that make sense? If the smaller function is growing exponentially, then the bigger function has to grow exponentially too. Now the reverse of that is if the bigger function from a to infinity of g of x converges, that means that from a to infinity f of x has to converge as well. So this means that the bigger function, if the bigger function is approaching some value, the smaller version has to approach some value as well. The smaller function can't just go up and diverge. Okay? Now let me ask you, if we know that the bigger function g of x diverges, what do we know about f of x? If we know that the bigger function diverges, we don't know anything about f of x. Okay? because the f of x function could still diverge or it could still converge. We can only be sure of these two relationships. If the smaller function goes off to infinity, then the bigger function obviously should go off into infinity too. And if the bigger function can't go off into infinity, it converges, then the smaller function has to converge as well. So let me write that down. If the bigger converges, therefore the smaller converges. If the bigger diverges, then the smaller. If the smaller diverges, then the bigger diverges. What? So yeah. So you have to make sure that one of these conditions is happening. If you have the smaller version converging, we don't know anything about the bigger one. The bigger one could still converge or diverge. But if you know that the smaller one is diverging, then the bigger one has to diverge. Let's see. Yeah. What do you mean, which test? Yeah. So this test has its limitations. So let's say we have the function 1 to infinity of e minus x to the minus x squared dx. So that's our f of x, okay? So 0 is less than or equal to e to the minus x squared. What g of x could you guys think of that we could use in this situation? 1 over e to the x, okay? No, you try to choose something similar to it.
Yeah, like because that's why like there's so many functions you could pick.
But you try to find a function that's very similar to it. For x is greater than 0. Greater than or equal to 0. So do you guys see? Now we know e to the x is bigger than 1 over e to the x squared. Okay? If we find that e to the x converges, then we know 1 over e to the x squared converges. If we find that this diverges, we don't know what's going on. Okay? So then we do that integral, since that integral is easier to do. That's equal to the limit as b approaches infinity. You have to remember improper. What's the integral of e to the minus x minus e to the minus x from b to 1? That's equal to the limit as b approaches infinity of negative 1 over e to the b minus, but then we added 1 over e Okay. This goes to 0 because e to the b in the denominator goes to 0. We are left with 1 over e, which is converging. Therefore, the integral from -1 to infinity of e to the minus x squared dx converges. And we have by direct comparison. Where?
On the bottom.
I should be.
Okay, there. Go down. Yeah.
I think most of the time you'll just do limit comparison tests. Yeah. Okay. Any questions on this? Can I raise it?
I think it was a function of how easier to know whether it's faster.
Just go with. We're on the practice exam. They tell you limit comparison. Like they tell you to use the limit comparison test.
Which was faster than
Sin of x doesn't grow.
Obviously.
Yeah.
Okay.
That you will learn more about when you do Eaton. About waves and growth and stuff. All of it on video. These conditions, so, but DE is only on Tuesdays and Thursdays. So it's only a 2-credit hour class.
Yeah, but it is instead of next thing we are learning like we do what we would learn a lecture outside and it's class.
These conditions must be true. F of x and g of x have to be positive functions. Second, f of ng have to be continuous. On the interval from a to infinity. Positive functions. You have it? So there are some steps. First step is you have to find g of x, which is similar to f of x. Second step, you do the limit. as x approaches infinity of f of x over g of x. And you should get a number. Yeah, I think so. And you don't use the linear person test. There's like a whole bunch of tests, like the ratio test and a lot of other things that you guys will learn to compare two functions and whether they converge or diverge or what they approach, because you can't do it for every function. 2, determine behavior, converge or diverge. With the integral of g of x. And then 4, make a conclusion of f of x. Good? To infinity. You guys, like, they did this in class, right? Or, yeah. On Thursdays, do they teach or do more of like homework review? What does group work mean?
First of all,
Yeah.
and then they put up a problem and you're supposed to sit next to somebody and you're supposed to like try and solve it and then somebody can. Which used to be like optional, so now like not a whole come and then
Yeah. So we had our Tuesdays optional, and I went the very first week of college, and that's it. So it's from 2 to infinity. But it's very, no, I went in Calc 3. Calc 3 I needed to go. Us it was just homework review, like you guys had in Calc 1. Because Calc 3 gets crazy.
So would they teach material Wednesdays?
Yeah. So Monday, they did homework review on Monday, because our homework was always due Tuesday nights, and we had quizzes online on Tuesday nights, and then tests on Thursday. So they went over the homework on Mondays. The rest of the days they taught. So the first step is what? Finding. Guys. Finding g of x. Yeah. So we have to find g of x as x approaches infinity. So this is how we find it. We do x approaches infinity of the function x cubed minus 1 over x cubed. So if we're approaching, or I don't know, just by looking at this, we know that the -1 does almost nothing. So we have x cubed over x, yeah, square root of x cubed over x cubed. And if you were to simplify this, that's equal to 1 over x to the 3/2. Or, yeah, 3/2. So that is x to the 3/2 over x cubed. So this is now our g of x. The next step is to do the limit of f of x over g of x. What you guys can do. Make sure you, so I'll write it.
Well, if you guys do what f of x is as it goes to infinity, that's like one.
No, this is just, like, this is not equal to that. This is very similar to it. So,
So, what do you,
we're not really saying as x approaches, x goes to infinity of f of x.
just
Yeah, we
take out
just,
the one.
yeah, we just look for a similar function like that. Because, yeah, if we are at infinity, the 1 does nothing. Yeah. So then, some people by mistake write it wrong, but you have x cubed minus 1, that can divided by x cubed all over 1 divided by x to the 3 halves. So then this can go on top. So then if we go and try to simplify that, we have limit as x approaches infinity of the square root of x cubed minus 1 divided by x to the 3 halves. This is x to the 3 halves. Okay. So we can actually rewrite this. So we bring this inside. We are left with 1 minus 1 over x cubed. And this, as x goes to infinity, equals 1, which is equal to L. Since we got L, now we know, well, we got 1, and we know 1 has to be less. We know 1 is between 0 and L. Now we can do the integral. What is that? We know 1 is between 0 and infinity. Now we know we can do the integral of g of x to find whether it converges or not. What? Yeah. So the third step is doing the integral of g of x from, so we have the integral from 2 to infinity. Our g of x we found was 1 over x to the 3/2. So that's x to the minus 3/2 dx. What would the integral be? Again, we have limits as b approaches infinity. So if you do the integral, you get x to the negative 1/2 divided by negative 1/2 from 2 to b. That's equal to the square root of 2. When you guys work it out, it equals square root of 2. So g of x converges good. You guys write that down. This, that's they give us. It's going from 2 to infinity. And then our fourth step is therefore the integral from 2 to infinity of the square root of x cubed minus 1 over x cubed dx converges by limit comparison. Any questions about this test? It can be tricky because once you do enough of them, like 2 or 3 of these problems, it should be fine all of them. So shouldn't be terrible afterwards. And then there is, yeah, that's pretty much it. And then there's like methods of integration that you guys should know, like completing the square, but that's not really important. But you guys can figure those out. That is it. Yep.